In this video, we are going to be focusing on carboxylic acid derivatives. Carboxylic acid derivatives come from the idea that these are going to be molecules made from carboxylic acids. As you can see in this slide, we have the most common derivatives of carboxylic acids. The first one is known as an acid halide, in which the most common one of the acid halides is going to be an acid chloride. Understand that the green boxes that are highlighted throughout these molecules, except in the case of the nitrile, they are going to be the carbon atom that is going to come from the carboxylic acid. The atoms that are in red are going to be the ones that are added to and are different from the original carboxylic acid. The second type of carboxylic acid derivative is an acid anhydride, and as you can see, that C double bond O that came from the carboxylic acid is now going to be attached to a single bond oxygen. That single bond oxygen is going to have a C double bond O, and then that is going to be attached to an R group. That R group can be hydrogen or it can be an alkyl group. When it comes to an ester, we're going to have a C double bond O bonded to oxygen, bonded to an R group. But in the case of the ester, that R group is going to be alkyl or aryl. What that means is that R group must start with a carbon atom in order for something to be considered an ester. And lastly, we have amides, at least in the top row. And an amide is when we have a C double bond O bonded to a nitrogen. Now, in the molecule that we have presented in the slide, it is illustrated as an NH2. But understand that amides can be substituted, okay, at the nitrogen atom. So that nitrogen does not need to be NH2. It can actually have carbon atoms around the nitrogen, but it's still respecting the octet rule for nitrogen, which establishes that the most common bonding pattern for nitrogen is going to be 3 bonds and a lone pair. So we can have at that position at least 2 alkyl groups. It could be an NH2, it could be an NHR group or an NR2 group. Now, understand that when it comes to any compound where carbon has 3 bonds to an electronegative atom is a carboxylic acid derivative. That's why a nitrile group, as you can see in the bottom, is also considered a carboxylic acid derivative. Now, when it comes to acid halides and acid anhydrides or anhydrides, they are relatively unstable and they are not common in nature, okay? They're not organic compounds that we see commonly. Now, esters and amides are actually abundant in nature. And just to give you an example of esters, as you can see in the bottom, and again, we know that it is an ester because we have that C double bond O, OR group in each one of these motifs. I'm highlighting this in blue. These are going to be different type of esters. Now, esters, understand that they are going to be molecules that we can commonly find as the compounds that give us the smells of different fruit. And as you can see here in the slide, we have specifically pineapple, banana, and pear. Now we're going to go through the nomenclature of these carboxylic acid derivatives. To name an acid halide, we are going to be replacing the ic acid of the carboxylic acid name with IL halide. So for example, in the first molecule that we have acetic acid. So in this guy, this is a acid bromide, but we are going to change from acetic acid to acetyl bromide. For example, if we have the acid chloride for that came from benzoic acid, as you can see, this is benzoyl chloride. So again, we are just going to replace the ic acid out of the name, and we're going to put YL and then the name of the halide. If it's bromine, as you can see here, then it's going to be bromide. If it's chlorine, then we're going to have chloride. If an acid halide group is connected to a ring, the suffix carboxylic acid can be replaced by carbonyl halide. So as you can see here, the molecule that we have on the left, the carboxylic acid is called cyclohexane carboxylic acid. So the name of the acid chloride is going to be cyclohexane, and then the carboxylic gets changed to carbonyl, and then the carboxylic acid gets changed to carbonyl, and then we have the name of the halogen. So in this case, because we have a chlorine, that's why we have chloride as the last word. When it comes to acid anhydrides, they are named by replacing the acid word in the carboxylic acid by anhydride. So as you can see here, we have acetic acid. So the corresponding acid anhydride is going to be acetic anhydride. And as you can see in the first, we have succinic acid. So the product is going to be succinic anhydride. Now, understand that in the example of the succinic anhydride, structurally are going to look different because, again, this is a carboxylic acid derivative. Later in the chapter, we're going to see how the chemical conversion of these two things happen. So as of now, we are just naming. So when it comes to asymmetrical anhydrides, they are named by listing the acids in alphabetical order followed by anhydride. So as you can see here, in this molecule, I'm just going to highlight the different groups. So this portion of the molecule is acidic. This portion of the molecule came from benzoic acid. That's why at the end, since this whole thing, let me just use a different color. Is an acid anhydride. That's why the last word is anhydride. When it comes to esters, they are named by first naming the alkyl groups attached to the single bond oxygen. Then we name the carboxylic acid name, but then instead of putting oic acid at the end, we're going to have ATE. So for example, as you can see in the molecule that we have in the box, the ester was formed from acetic acid. So if I highlight the atoms, this portion of the molecule that I am highlighted in gray came from acetic acid. And again, we're going to learn synthesis further in the chapter. So that portion came from acetic acid. So we're going to remove the ic acid from the acetic acid and put ATE as our ending. The first word, as you can see, ethyl, comes from the group that it is specifically attached to the single bond oxygen. In the case that we have an ester that came from a carboxylic acid in which the carboxylic acid is attached to a ring, system, a cycloalkane ring system. As you can see here, similarly, we are going to first write the name of the substituent in the single bond oxygen, that in this case is methyl. That's where this word comes from. Then we're going to put the name of that cyclic molecule that is attached to the carbonyl. That's where the cyclohexane name comes from. And then remember, the carboxylic acid name, that's how we named it previously, is going to not have the ic acid, and then we're going to replace that ic acid with specifically ATE. When it comes to amides, amides are named by replacing the suffix ic acid with or oic acid with amide. So it depends if the carboxylic acid has an ic ending or an oic ending. At the end of the day, remember that we have to add the word amide at the end. So as you can see in the first box, to give you an example, the name of this amide, because it came from acetic acid, is acetamide. And in the bottom, this is the amide that came from benzoic acid, so that is known as benzamide. Now, if the amide group is connected to a ring, then the carboxylic acid word is replaced by carboxamide. So as you can see in the example, here we have a cyclic system, which is where the cyclohexane came from. And because now that is attached to an amide motif, that's, where previously the carboxylic acid will be placed, but now because we have an amide, then that is known as a carboxamide. If the nitrogen atom of the amide bears alkyl substituents, their names are placed at the beginning of the name with an N as their locant. And that's going to determine that they are at the nitrogen part of the amide. So as you can see in the first example, here we have a methyl group bonded to the nitrogen in the amide. That's why we have N-methyl. This group is an acetyl group, so that's why it is acetamide. Here, as you can see, we have two methyls. So we have that di substitution on the nitrogen. That's why we have N, N, dimethyl, to symbolize that we have two of the same ethyl. N, N, dimethyl acetamide. Understand, I was just getting ahead of myself. If you have different substituents on the nitrogen, let's say that it would have been, I'm just going to draw an example here. Let's say that my nitrogen is substituted with things that are different. Then here I will say N-ethyl, N-methyl, acetamide. Because I'm giving the location of my substituent as a prefix of the longest carbon chain. So as you can see, that's the N-ethyl. This is the N-methyl. And then the acetamide comes from that portion of the molecule. Remember that whenever we are putting the location of the substituents, they are always organized in alphabetical order. That's why we have the ethyl before the methyl. Lastly, we are going to go over naming nitriles. And nitriles are named by replacing the ic acid or oic acid with O-nitrile. So, if your nitrile came from acetic acid, as you can see, that is called acetonitrile. If your nitrile came from benzoic acid, then that is benzonitrile.